Hello guys and welcome back to another video assignment, and my name is Paranithan and I'm studying in Sri Venkateswara College of Engineering in the Department of Computer Science and Engineering, pursuing my 7th sem. And today we are going to be doing the last video assignment of this sem, and we'll be talking about IoT topologies. As we know, Internet of Things topologies define the structure and arrangement of how IoT devices, gateways, and communication systems within a network work. Below are the main IoT topologies, each suited for different use case and environments. So there are basically 8 topologies, namely star topology, where devices and nodes are connected to a central hub, where there can be many devices where they'll be ensured at one converging point, which is your central hub. Mesh topology are where nodes are interconnected and data can be transferred between the nodes either directly or via other nodes. Nodes are connected to each other and the communication happens between the nodes, and there is uh, no central node. Tree topology, hierarchical arrangement where devices connect to the parent nodes, which in turn connect to the central hub or the root node. Ring topology, devices are arranged in a closed loop with each node connected to two others. Bus topology, all devices share a single communication line, bus. Hybrid topology combines two more topologies to leverage the strengths of each. Fully connected topology, every device is connected to every other device directly. Cluster topology, devices are grouped into clusters and communication occurs within and between clusters via cluster heads. Introduction to the IoT architectures. IoT system components. IoT systems typically consist of three core components: sensors, devices that gather data from physical world; actuators are the devices that perform actions based on the collected data; and network is defined as the infrastructure that connects the devices and enables data transmission. IoT architectures define how these components interact and communicate. Different topologies offer different levels of complexity, scalability, and performance. Centralized IoT topology, which is your star topology, where there will be many nodes which will be connected to a central hub. So it goes on with centralized data processing, where all data from devices is collected and processed by single central server, and the communication happens between the node and the server and not between the node to node, as they are not connected to each other and they are only connected to the central hub. And if there is a single point failure, describes that if there is any breakdown in the central server, it becomes critical and can disrupt the entire system. The central server becomes a critical component, and as its failure can disrupt the entire system. But it is more simple and cost efficient compared to your mesh and tree and other topologies. This topology is relatively simple to implement and very cost efficient. Decentralized topology, as you can know, there is no existence of a central hub, and all the nodes will be connected to each other or their parent nodes. So here we can see peer-to-peer communication, where devices or the nodes connected to each other can communicate between each other, and devices communicate directly with each other without a central server, enhancing data sharing and collaboration. Improved reliability, in the sense the decentralized approach makes the system more resilient, as failure of one device does not affect the entire network. As discussed previously, if there exists a central hub in a topology, the central hub failure can lead to disruption of the entire system. As in decentralized topology or the mesh topology, exists no centralized hub, and any node failure does not disrupt the entire network. And increased complexity, managing the decentralized networks with many devices can be challenging, and the cost is also preferably more compared to the centralized topologies. Hierarchical topology, layered structure. A hierarchical topology utilizes gateways to collect data from sensors and actuators before forwarding it to a central server. Scalability. This topology is scalable for allowing the addition of new devices without overwhelming the central server. Optimized performance. Gateways can pre-process data, reducing the workload on the central server and enhancing performance. As we said, in mesh IoT topology, there is high connectivity, complex implementation, and enhanced security. Mesh networks provide robust connectivity as data can be transmitted along multiple paths, making it resilient to device failures. As peers to peer are connected to each other, and the communication can happen between any nodes across the topology, where it doesn't have to go to the central hub and request data and then transfer it to the required node. And enhanced security, in the sense mesh networks often incorporate strong security protocols as each device can act as a relay, encrypting data along the transmission path. Complex implementation. Managing mesh networks can be complex, and the cost for routing are also high, which require advanced routing protocols and network management tools. Now let's talk about the factors influencing the IoT topology selection. Application requirements. The specific require functionalities and demands of the IoT application will guide topology choice. Network infrastructure. Existing network infrastructure constraints and available bandwidth influence topology decisions. Security considerations. Security needs dictate the choice of topology, with mesh networks offering enhanced security features. Scalability and cost. Long-term growth, budget constraints, and operational cost considerations influence topology selection. Conclusions and the key takeaways of this PPT. The choice of IoT topology is critical for achieving the desired functionalities and performance of an IoT system. There is one size no one size fits all solution. The right topology depends on factors such as the specific application requires, network infrastructure, security concerns, and scalability needs. By carefully considering these factors and understanding the advantages and disadvantages of different topologies, you can select the most appropriate architecture for your specific IoT deployment. And that is the end of the video, guys. And if you have found any useful information, please leave a like. Thank you.